Video physics involves the analysis of video to collect data on the trajectory, location, and velocity of objects moving in space. In our example, our goal was to determine the velocity or speed of a vehicle driving down the street. Review our online material for comments on other projects and links to online information. We used the simple video camera to capture a record of the vehicle's movement. Watch closely because the relevant segment, the passage of the black truck, takes only a second or two. Here's the crucial segment of the video clip. Once recorded, the short video file is loaded onto the iPad and then opened with the Video Physics app. The software makes use of some known distance that you identify within the video, and the capacity of the software to identify consecutive frames and the known time interval between each frame. You mark the same object in each frame, not necessarily an object of known size, and the software can determine the distance this object moves and the velocity of this movement. We were interested in estimating the speed of a vehicle over the distance of a few feet, but in other experiments, change in direction and velocity might be of interest. For example, one of the demonstrations from Vernier tracks a basketball free throw. Because we own the vehicle, we precisely measured the distance between the axles of the vehicle. This turned out to be 9 feet 2 inches. The hubcaps have distinctive centers that are easy to pick up on the video. Because this known distance was part of the vehicle used in this demonstration, this was ideal. We would not have access to this known distance if we had decided to check the speed of random vehicles driving down our street. We might then have used the width of the driveway as it entered the street as an alternative. The second step is to identify a common point on the vehicle in each successive frame. Again, the center of the hubcap was easy to target, and you can see the series of blue dots marking the position of these points from frame to frame. The video physics software is able to extract multiple variables and graph the relationship among these variables. The graph you see here probably makes the most sense. The graph indicates that we collected data over a surprisingly short period of time, less than 0.6 of a second. And in this time, the truck moved down the street slightly less than 2 units of x. The app asks that we define our known difference in meters, but it might be more useful to remember that our known distance is 9 feet 2 inches. In other words, in less than 0.6 of a second, the truck moved approximately 18 feet. The data from video physics can be moved from the iPad to a Vernier software product, Logger Pro, on a computer. One of the nice things about this transition is that the precise numerical values now appear in a spreadsheet. If we want, we can do some calculations. You will note that between the time markers of 9.9 and 10.4 seconds, a difference of 1/2 second, the value of x changed from 0.1126 to 1.879, a difference of 1.66 units. A unit is 9 feet 2 inches, or 9.17 feet. In 1 second, the truck would have traveled approximately 32.4 feet. Multiply this value by 3,600, and the truck would travel 116,640 feet in an hour. Divide by 5,280, and it appears the truck was moving at just a fraction over 22 miles per hour. So from the video alone, we were able to determine the speed at which the truck was traveling.